You are in Augustus 3.4. This is the track on enterprise concerns. The talk is Corporate Espionage for Dummies, the hidden threat of embedded web servers. And here's Michael Sutton to talk to you.
Great, thank you. Thanks for coming, everyone. Good to see a few people decided to come to a talk instead of lining up for their DEF CON badge for hours on end. Isn't this DEF CON 19? Shouldn't we have figured out a better system for the badge distribution at this point? Apparently not. How many people run a web server at home? A few hands? I would argue that virtually all of you run a web server at home. You know, we don't necessarily think of it as such because a lot of them are now embedded in hardware devices. Like I know that at the Sutton household I can think of 3. My printer has a web server, the webcam that I use to keep tabs on my newborn has a web server, and I have a network attached storage device for backup, that has a web server. Before I started this research, I didn't really think of those devices in that context. And it was amazing to me as I went along just how many devices, like it is pretty standard. If you have a network connected device, there's a really good chance it has an embedded web server in it. The thing that got me turned on to this research was about a year ago, our family has a cabin that I was staying at, and we often go up there to work, so we have internet access and printers and things like that. And just out of curiosity, I was scanning the network, saw that the printer was online. I thought, oh, that's interesting, just a standard HP printer. And started poking around, and I started to think to myself, you know, some of this functionality I wouldn't want an outsider to have access to. It could really be abused. And started to look at, you know, how many of these devices were actually externally exposed, and was really blown away by just how prevalent embedded web servers were. So that was kind of the catalyst for the talk. And I called it Corporate Espionage for Dummies because I felt that that was very appropriate. As I started looking at this, I'm like, wow, like, you really don't need technical expertise. This doesn't even require hacking. If a company has made a mistake or accidentally or unintentionally exposed these devices, you're really handing out corporate secrets. So I'd like to dedicate this talk to the #1 corporate espionage guy, Mr. Rupert Murdoch. This one's for you. Hopefully you'll get a few tips out of this talk. You can move on from just that voicemail stuff. So a little bit about my background. I focus on web security, more specifically client side. I'm the Vice President of Security Research for Zscaler. We're a company that's built a SaaS solution for client-side web and email security. I'm a startup guy. This is Zscaler's startup number 3. Before that, it was iDefense and Spy Dynamics. I really love, you know, getting with great groups and building new technologies. So this is kind of the course of events that I want to go through. I want to talk a little bit about the current state, you know, what we're seeing out there today. Then I want to spend the bulk of the time on the threats themselves. I have a variety of buckets of embedded web servers that I came across that I felt had security consequences, and I want to talk through each of those. And then at the end, on the solutions piece, I built a scanner that you can use to scan your network to identify embedded web servers that may or may not be there, and then just talk about some of the solutions, the things that we need to do to address this. So what does it mean to be in this hyper-connected world where literally everything is online and everything has an IP address? So think of, you know, I mentioned to you the things that are in my home that actually have embedded web servers. So think of the things that are network connected in your home. Television sets, DVRs, Blu-ray or DVD players, webcams, telephones, video game consoles. Now we're starting to even see large appliances and small appliances. Now, not all of these would necessarily have an embedded web server. Sometimes it's more of a client side, almost more browser-like, where it's sending data out. But very commonly, devices, hardware, now comes with an IP address. It is connected, it is online. Now let's think about the office. We have items like printers, scanners, photocopiers. I'll talk about those in a minute. They offer some frightening consequences if they're not properly locked down. Security systems, networking hardware, obviously, but I mean from an embedded web server perspective, video conferencing, network attached storage, even HVAC appliances. There's a lot of systems out there that you can find on the web where actually people's environmental systems are online, and you can see them, you could even mess with them if you chose to. Now, when I keep saying embedded web server, but what is an embedded web server? I mean, I don't feel that there's any universally accepted definition of what that is. So from my perspective, it requires these 4 pieces before I would consider it an embedded web server. It has to be installed on the hardware. So this isn't something that you install yourself. That was done when the device was manufactured and it's shipped to you. This is not something that's designed for high performance. It's actually designed for administrative purposes, as you see in number 4. So it really has limited functionality. This isn't something you're going to use to host your own pages. It's basically an administrative interface to be changing and enabling and disabling functionality on the device, or to use certain features. Like with a photocopier, for example, you may be able to download digital copies of whatever was printed on the particular device. So just public service announcement. No embedded web servers were harmed during the course of this research. Everything that I'm going to show you was completely publicly exposed. This didn't require, brute forcing a password or anything like that. So I think the frightening thing is everything that I'm going to show you was completely exposed, definitely should not have been. But you could take it a step further, 2 steps further. The first step being a lot of devices have default passwords. And how hard is it in this day and age? Pull up the user manual. Oh yeah, default password of password. Okay, I put that in, I bypass it. And very often companies just don't even know that the web servers are there, so they're not doing anything about it. And then think of all the devices that are on LANs that obviously I wasn't able to see because I was only focused on the web. Every company has a photocopier. Every company has a printer, a scanner. And I expect that many of them have embedded web servers, and I expect that many of them are completely exposed. How many people are firewalling off their photocopier? So hey, somebody put up their hand here. That's great. That's what I want. I want everyone to go set up a firewall when they get back. So what are some of the threats? Well, some of them have lesser security consequences. Like, yeah, I could perform a denial of service. Okay, you can't use your printer. That would be more consequential for something like your telephone system. Privacy, in my opinion, that was the big thing that came out of my research. And that's why I called it corporate espionage for dummies. I mean, you can really tap into enterprises if they don't have these devices locked down, whether that be eavesdropping on a phone call or retrieving a confidential document. Data integrity could be an issue because you could be changing things once you have access. Could be financial consequences. If somebody, for example, got into your phone system and was using it to make calls, there could be an implication there, or even bandwidth costs. And you could even have full root compromise. I mean, a lot of these devices will allow you to upgrade the firmware remotely, and if you're inclined to do so, you could actually write custom functionality and leverage this as a backdoor to the system. So I focused on the external threat because I was scanning the public web. I wanted to see just how bad this situation was, how exposed things were. In my opinion, the greater threat, though, is the internal one. Because as I'll demonstrate, it was not hard to find literally thousands, tens of thousands of these devices that were completely unprotected. But again, think of the millions that are inside the corporate LAN. And enterprises just don't think of it that way. Like, your last pen test security audit, did they scan the photocopier? Probably not. Your patch management process, does it take into account that firmware needs to be upgraded on the VoIP system? Unfortunately, it probably does not. There's all kinds of crazy stuff out there. This was from a couple of years ago. This is actually in Security Focus. There is a report on vulnerabilities in an internet-connected espresso machine. Guy found a buffer overflow in that. Not sure there's significant security consequences, but if you're like me, being denied access to your coffee in the morning, we take that very seriously. One of the items that I feel will continue to drive embedded web servers in appliances is the concept of energy savings. Like that's, today, very often, especially when it comes to appliances, much of what I saw, I felt that the embedded web servers were a bit gimmicky. I didn't always feel there was a reason to be there, but that allowed them to charge a premium because it's an internet-connected coffee machine. But energy savings is something that is going to be driving this whole smart appliance. Your appliance will run at a lower speed when costs are higher for your energy. So I expect we'll see more and more of this, and that is a piece that will be driving things. I saw some things that just made no sense to me as I was walking through. Like, here's a projector. And so I'll talk about how I focused on header fingerprinting to identify things. And so this one, HP is very kind to you. They give you very unique server headers. And server headers aren't all that reliable when you're talking about traditional web servers because they can be spoofed. You really don't have to worry about that with an embedded web server because you just don't have that access, you don't have that functionality. So if you scan your network and you see microchai, that is an HP projector. Or I'll mention Shodan. Some of you may be familiar with that site. It's like Google for server headers. So if you put in microchai and Shodan right now, you'll find this one somewhere in the US. But what is the point? Why do I need to have my projector exposed to the web? So this shows me that a lot of this, I'm assuming, is network misconfigurations. People are making mistakes because I can't see any purpose why I need to, when I go home from the office, be able to make sure that my projector is still on and working appropriately. Here's another projector. I like this one. This is a Sony projector. Again, the server header fingerprinting works really well because it's called Network Projector, and it's the only device that I've ever seen that is called Network Projector. You can actually remotely operate this one. So, if you want a good office prank and you find one of these, wait for the meeting to start, sit back at your laptop, start changing the focus in and out, and turn it on and off, and watch that meeting fall apart. I mentioned very often I found that these things were gimmicky. So here is an Epson printer, and that is the only page that the web server serves up. There are no buttons other than the refresh button. So all that it tells you is that your printer ink level, what it's at. If you are too damn lazy to walk to the printer to check the printer ink, you are also too damn lazy to walk to the store to buy new printer ink. So I'm not sure I really understand the purpose of this particular one. I also very often found kiosks. So, there was no reason for this to be exposed to the web. Like, you'll see the UCLA one, like it's asking you to swipe a badge. Obviously, I can't do that when I'm sitting at my laptop. But again, it just highlights the fact that there's a lot of network misconfigurations, things that really have no need to be exposed to the web, obviously are. So when I was doing this research, I got interested in it. I said, I want to know how much stuff is out there and what is out there. Like, what are these embedded web servers? And then what are the implications of them being exposed? So my plan was, I said, I need to get a lot of data. I need to scan a large block of the internet to identify what's out there. So the challenge is twofold. One, how do I make that scalable to be able to do that? And two, how do I identify these devices? Like, how do I differentiate a photocopier from somebody's website? So my approach was, I considered three different approaches. One, traditional scanning tools, like an Nmap, for example. Google hacking was another option. And then the third was the header fingerprinting. And just to illustrate why I went down the path that I did, like Nmap, absolutely fantastic tool. It's pretty hard to be in the security industry and not have benefited from it. But it's really not designed for embedded web servers. Like, here's an example of a scan on this is a Canon photocopier. And you can see it gives you a lot of different options. There are a couple of Canon copiers in there, none of which were actually the exact version of this particular one. But it's really all over the board, even things like an Apple Airport Express. So Nmap wasn't going to help me in this particular situation. Next up, Google hacking. There was talk on it yesterday. We've all come to know and love Google hacking. I argue that Google hacking is actually getting less valuable over time, and I'll explain why. But one of the challenges that I would have faced if I had solely relied on that is, so let's say I wanted to use Google hacking to find this particular Canon photocopier. I mean, lots of unique strings on the page that I could take advantage of. We've got the copyright notice, some model numbers, the device status. Those actually all work really well, and I can get Google hacking information on that. But what about this? many of these embedded web servers, they have simple localization settings. You go into the administrative console, you say I want it in Japanese, German, whatever. Well, now I've narrowed my results. I'm not going to get back the same results. I would have to do my Google hacking in multiple languages. But in my opinion, the bigger problem is, like, Google knows you're doing this, and they don't want you doing this. They don't want to be the search engine for hackers. So I firmly believe that they are suppressing queries, and I'll show you some evidence of that. Like you'll see in this case, looking for that Canon photocopier, I found about 127 devices. Keep that in mind. The internationalization causes a problem. If you're using their API, they don't want you doing millions of queries a day, so you're restricted to the number of queries you can do. And also, you can get blocked. Like, while I was doing this research, I was automating some things, and I was actually finding that I was getting blocked. Not clear if it was due to volume or it was due to the fact that they didn't like the search terms. But regardless, there are limitations to using Google hacking for this purpose. So the last approach that I considered was header scanning or header fingerprinting. And again, it's not all that reliable for, if I was just looking for web applications, but I found it to be very reliable for embedded web servers because they tended to have very unique strings. Like this is, a Canon photocopier. So my approach was, this is what I did. Leveraged Amazon EC2 for the scanning because I wanted to have a lot of instances running, simple Perl scripts to do the scanning. You can run an Amazon micro instance for free now if you only want one of them. So I found that this was very highly scalable. I could automate this. I could get my million servers, get my statistics. It actually worked very well. The only real challenge is that there are times when you don't have a unique server string. I did see situations where no server string was returned. And also, there are companies that make embedded web servers. So the string that came back, maybe like ROMPager, for example, is an embedded web server that you see in millions of devices. So maybe I get that back. So I know it's an embedded web server, which helps me with my overall stats, but it wouldn't help me to know that this was an HP printer without digging a little bit deeper. But overall, I found this to be a very good approach, and this is what I leveraged. I mentioned Shodan. How many people have used Shodan? A few hands. Really powerful tool. Unfortunately, I think it offers a lot more to the bad guys than the good guys. So think of it as just Google for server headers. So I can't go to Google and say, hey, give me back anything that has a particular server header. That's exactly what Shodan is. So basically, I was creating my own personal Shodan because I wanted to do all different things. And it's a commercial service. You get 10 results for free, 50 if you register, but you have to pay thereafter. And I'm cheap, and I didn't want to pay, so I just did it myself. But it was actually a very valuable tool during this research. If I wanted to check something, how many servers are out there, how many scanners are out there, and you'll see I include stats throughout from Shodan so that you can recreate that, and you can see just how big some of these numbers are. And so, I said before, only 127 results from Google hacking. You can see simply using the server header, which in this case is very unique on Shodan, a couple thousand. So I'm very confident that Google is suppressing some of these results because they don't want you doing this. So OK, now that we have the background, let's dive into actually looking at the different categories of embedded web servers that turned up. So we've put a web server in every device imaginable. We've plugged it into the net. What could possibly go wrong? So first up was printers, scanners. And I mentioned, this is what first got me interested when, I scanned our own network, saw this HP all-in-one printer scanner, started looking at some of the functionality and thinking, wow, I really wouldn't want this exposed to the outside. In fact, I wouldn't even want somebody in my home network that got on my Wi-Fi and was able to do this. And let me explain why. So HP, the whole server header fingerprinting actually works really well. They have some unique ones, like those HP Chai servers you saw on the projector. It was like micro Chai. So that's one that's unique to them. All those project revisions are pretty unique. They do Verata MWeb is actually a product. That's a company that makes embedded web servers. But the nice thing is very often they have these revision numbers, and the revision numbers do actually tend to be unique to large vendors. So 621 either was made for HP or they bought the bulk of it. Because if you do a showdown for that, virtually everything you'll find is an HP printer scanner. So, and you can see the numbers. Like, there are definitely more than that, but those are the ones that were more uniquely, I knew that 90x% of them were HP printer scanners. Look at 100,000 devices exposed to the web, and it was as easy as just, typing this into a search engine. Very often these things are not password protected. The HP devices, they all come by default, everything turned on, not password protected. I thought it was actually interesting when I looked at different types of printers. I found that the PhotoSmarts tended to be less likely to be password protected than the OfficeJets, which are targeted at an enterprise audience. But still, many of them were purely exposed. So what's the point of even having an embedded web server and a printer scanner? Well, it's to manage the devices, change network settings, as I showed you before, check ink levels. I don't know why that's so valuable. So what could I do to this? I could reconfigure the device, I could mess with you, I could, shut off your printer, big deal. But the two features that I found particularly concerning were, one, a feature called Web Scan, which allows you to remotely operate that scanner, and the second one is something called Fax Forwarding, which allows you to redirect an incoming fax. So let's take a look at those. So here's Fax Forwarding, fairly standard feature on HP all-in-ones that have fax capabilities. So again, 100,000 of these devices exposed, I can go in and I can say, hey, anytime you get a new fax, I would like a copy sent to 1-800-Michael-Sutton, just to make sure everything's cool. So if you've left this exposed, now anybody can get copies of your faxes. The other feature was this web scan. And you'll see it in different layouts. I mean, there are a few different formats for it, but it's been in HP scanners for the last 7-8 years. So if you've bought an HP scanner, good chance, and it's network enabled, good chance that you have web scan capabilities. So this allows you to remotely operate the scanner, which in my opinion is a fairly useless feature. This is a physical device that I must walk over to and place my document on it. Do I really need to be able to do that from my desk, like to get my secretary to put it there and then I push the button? So to me, concerning that it was there in the first place. Now, to operate it, you can do that preview button. It's called a quick scan. So during my research, I would use that to see if there was something on the server bed. And then if you actually do the scan, it does a full scan. And you can download that in either a PDF or a TIFF format. Or actually, sorry, this one was JPEG format. So when I first did this, I talked to people and they were like, yeah, but you got to find it. B, it's got to be not password protected. C, somebody has to have left a document on the thing. I said, all right, well, let's see if people actually do that. So ran the header scans, identified a lot of these devices, and then just started grabbing documents. And I had some people say, "What? You can't do that. That's evil." I said, this is a public web server. There was no warning saying don't come in. There was no password. How do I know they didn't want me to scan this document? So what kinds of things were there? Signed documents were there. Voting advice. This was actually from a Tea Party website, letting you know who to vote for in the next election. I'm actually a Canadian citizen, so it was of no use to me whatsoever. Signed checks were there. Technical reports, various forms, and my absolute favorite, documentation letting us know that Jim is now a certified mold inspector. Let's hear it for Jim. Way to go, Jim. Thank you. So prevalence, you'll see this web scan functionality all over the place. Again, like I would encourage you, when you go back to the office, if you have scanners, take a look. If you have an HP scanner and you've bought it in the last 7-8 years, very good chance it's there. So, and again, it is always enabled by default, no password. It's easy to find this stuff. And also another thing, you wouldn't necessarily have to catch a document when it was actually there, because once you scan a document, then you can retrieve it remotely, like the website that I just showed you. So it is now stored on that device. If you knew the URL, you could retrieve it even when the document wasn't there. And the URL is very predictable. Like everything in black is static. and then it's just the epoch time at the end. So you could very easily write a script in your office to just every second, run through and check to see if anything had been scanned. And then anytime anything had ever been scanned on that print or that scanner, you would be able to retrieve that. Photocopiers were the next item that I looked at. They were more frightening because, with a scanner, that document needs to be there. With a photocopier, photocopiers now are built with hard drives. They're built with embedded web servers. So what you do is actually stored and archived there. So Xerox photocopiers were one that I looked at. They were less interesting overall from a security perspective because the ones that I looked at were not actually storing archives of digital documents. Very easy to find. You can see some of the showdown results there. Very unique server headers. The top ones were Tektronix, which is actually just a division of Xerox. They bought it from another company in 1999. And then the Xerox themselves, they'll actually have Xerox in the server header very often. So what kind of stuff was there? You can get job accounting records so that you could see, what was actually printed, who printed it, things like that. Interesting, but not all that great. What's more interesting is that a lot of these photocopiers run FTP servers, and the FTP servers are anonymous. So awesome, now I have a place to store my wares in the office, right? I'm just going to stick them on the photocopier. Why this needs an FTP server that's totally not password protected, completely beyond me. Another thing that I thought was really interesting is, so it has these web links. So the idea there is that if somebody in the office needed to install a driver on their Windows machine, you could go to the embedded web server that was on the copier, and it just through the web-based interface download the driver. But you can also adjust that. So I will go in, I'll change it to, hey, evil.com.exe. Now anybody that goes to install those printer drivers, they're installing whatever I gave them, and you could use a remote URL for that. Again, not the sort of thing that should be exposed. Sharp photocopiers this is similar to the fax forwarding feature. So you could set it up so that you could add an address that would allow anything that is retrieved to be then forwarded remotely to you. So again, you could set up your email address, and anything that is processed by that copier will now be sent to you. You can see it's not just email. You could forward it to your own FTP or a network folder, desktop. So again, you find one of these on the corporate network, it's exposed, just have everything that's ever processed by that device sent to your inbox. The one that was the most concerning to me from a security perspective were the Ricoh Photocopiers. Again, very easy to identify these. That string web server /3.0, I've only ever seen that used in Ricoh Photocopiers. You can see the showdown results, nearly 20,000 that Shodan knows about, so not hard to find these. The functionality, there was two pieces of functionality that I found concerning. Again, they have fax capabilities in some of them, so you can get details of faxes that have been transmitted or received. The thing that was the most concerning was this document server, which I'll show you in a second here. One of my big beefs is that these devices often come password protected, but they come with a default password. How hard is it to go, this is a page from the user manual for a Ricoh photocopier, and it tells you right there, default password is admin. I mean, in my opinion, you may as well not have a password. Like, what is the point of having a static password? Either these devices should come with functionality disabled until a password is input, or they should have a unique password, something that is unique to that device. So taking a look at the Ricoh copiers, one of the items that I thought was interesting is you can have SSH capabilities to communicate with it. So I thought, well, that's kind of interesting. Yet when I scanned the actual devices, what I found, that looks like a lot more than SSH. I see Telnet in there. I see FTP. Now, there was nothing in the configuration console to allow me to enable and disable this. So what is the point of allowing someone to turn on SSH so that it's secure, but Telnet is running? You can see there, you have Telnet access to it. You have FTP access to it as well. Again, another great place to store your wares. So the faxes received feature, You know, you can see what faxes have come and gone. You couldn't actually get a fax, though. But the piece that was really juicy was this document server capability. And I found that you don't always see this in a Ricoh copier, but it's certainly pretty common. And basically, what it does is it stores a digital archive of the most recent documents that were scanned or printed or done whatever through this device. You can see, so this is a company's photocopier that I ran across on the web. And again, I'm sure that they wanted it to be a public web server, so why not let's sift through their documents. But so you get a preview of everything that has recently gone through it, and you can download it directly. I either choose a PDF or TIFF format, and I'll tell you, it was truly frightening to see just how many of these were exposed and how many documents were available. Now again, that was only what I was able to see on the web. Think of how many Ricoh photocopiers are sitting in enterprises around the globe, not firewalled, except in your organization, sir, I realize that. But you know, you would not go in and drop a stack of HR documents on an employee's desk, yet that's effectively what you're doing. You know, now anything that's processed by that copier is accessible if this functionality hasn't been turned off or password protected. Next up, security systems. I didn't want to focus a lot on this because I feel like this is actually a fairly well-known thing that, you know, webcams are very often exposed on the web. It's, you know, one of the more popular things that you hit with Google hacking. I did find it interesting. I found a lot of McDonald's webcams. I don't know why, but and there were different servers too, so it wasn't like they all used the same thing. And actually, most of the security, I would say webcams are the most popular, most common embedded web server that you run across when you're just looking for exposed devices. And most of what I saw were cameras set up to keep tabs on employees. Like it would be some camera that was clearly hidden somewhere and pointed right at some guy's desk to make sure that he was working all day. On the consumer front, you know, this is you very often see like Linksys, D-Link devices, and very often they have this like motion detection technology, which is, you know, all it's doing is matching different frames and doing a diff, and then you can email it off. But many of these were exposed, and so you could take advantage of this to literally physically spy on someone, right? I could, if they left their camera exposed, I say, hey, every time you detect some motion, send me an image. Not hard to find these devices. On the networking hardware, you know, it used to be that an attacker would be scanning, looking for exposed telnet, SSH sessions on networking hardware. Now it's very common that these devices come with embedded web servers. So Cisco devices are quite easy to find because, again, they have a very unique string, says Cisco right in it, and not surprisingly, a very big number, 400,000 devices in Shodan. Now, a challenge, though, is don't always focus just on the server header. Focus on all of the headers, because you'll see, you know, 400,000, but this particular one, you know, if you pay attention to the response code 401, well, that's likely a password-protected device. But, you know, you can expand it to look at, I change that query to, I just want 200 OK. Obviously, I drop way down to 12,000, yet now these are devices that are likely not password protected, right? And I just, you know, manually did a spot check. 33 of those first 50 completely not password protected. So, you know, if you're looking at all of the headers, you know, you can do different things with fingerprinting. So, you know, why is it there? I think we all know networking hardware. It's there to administer the device, you know, but obviously if I had that kind of access, that is frightening. You know, I could reroute your traffic, make it so that I am now a man in the middle and, you know, all of your traffic is coming through me. Definitely serious consequences. I found that a lot of this hardware was clearly really dated, and you could tell that by, you know, you'd get that warning screen that said, hey, you must be using Netscape version blah, blah. Oh, Netscape? What the heck? You know, or you'd see the copyright notice is literally, you know, 10 years old. And many of these I also found the initial, you know, router setup wizard would be presented to you. It's like, wow, nobody's ever touched this thing. Just, you know, snapshots. This is a very typical screen. Here's, you know, a newer, fancier one. Now you get a picture of it with blinky lights and everything. You know, but all of the functionality that you need to enable that, you know, I could turn on telnet, I could change the passwords, etc. And a lot of them have the full command line interface built into the web console. So you're not just limited to functionality. You know, this is traditionally how you would interface with a networking device. You can do all of that through the web front end. So we could really do anything if the web front end is exposed. Some of them have a ping tool. So great way to scan somebody's internal network, because now I've got access to a device that has access to the LAN. I can do a ping sweep. And you remember the outrage when Michael Lin was going to do his talk about how he found an exploit in iOS, and you know he could write his own code to a Cisco switch, and everybody got in an uproar. Well, why? You don't even need that. I mean, there are 12,000 devices that I just showed you that are publicly exposed, and I can upload my own firmware through the web interface. Next category, telephone systems. This one's for Rupert, because I know he likes this stuff. So a lot of different systems out there. They have unique strings for the most part. There was one Polycom that I found that actually returned an Apache string. That was not the norm. So very easy to find these ones, Polycom. I'll talk about 3Com and SNOM. Polycoms weren't all that interesting. You know, you could interface with it, change a few settings. Sapira was another one that was very common. You know, very often these ones were not password protected. When you'd find them, no password, but not that interesting. The SNOM devices are very interesting. I know that this is one that's been talked about in some Google hacking database circles, because they come with some frightening functionality. They have this debugging, all these debugging tools you can see down on the left that actually allow you to do traces and packet captures. You know, and I'll show you what they do. You know, this is definitely one of those features where in the planning session, the security guy was not in the room, because why would you want to be able to run PCAPs on your telephone, especially in something as a web console? You can actually, it will allow you to make phone calls. So, you know, you want a cheap phone call, go find somebody's SNOM and just do it through the web interface. But, and you'll see very often, you know, it tells you right in the top right-hand corner, hey, password's not set, but very common. So you can run some of these debugging tools, you could do a SIP trace, but this is the one that's scary. So if you find one of these systems that's exposed, it runs its own PCAP trace. So you can go into it from the web interface, say start the PCAP trace, leave it running for as long as you want, download that, get a newer version of Wireshark that can handle that kind of traffic. You open it, now you've just eavesdropped on phone calls. Like it literally does, you know, you think of, well, if I was a hacker and I wanted to eavesdrop, what would I do? Well, I would have to upload something that could capture packets. Well, they've taken care of all the hard work for you. 3Com phones, these ones I found very interesting as well. Again, not too hard to find. This is a situation where it's using a generic Verata MWeb as an embedded web server, but that string is reasonably unique to 3Com phones. You can see in these showdown results about 1,000 systems. Different interfaces, that's one of the newer ones. And you can also see that, again, the whole issue of, you know, pay attention to all of the headers, because even though the Verata MWeb, that is a little bit generic, you can see like the alternatives and the vary tag, those are not typical server tags. And so if you look at all that in combination to do some fingerprinting, you can be very confident that you found a 3Com phone system. This is one of the older interfaces. You can see it has that ugly stuff. This one feature, VPIM, it's hard to see what it is, voice, profile, something, something. But so it allows end users on your system, they can actually have their voicemail sent to them as a WAV file. So if you got access to this, you could set up somebody's mailbox so that any of their voicemails get sent to you in a WAV file format. And this, so I love this. So the top of this is the system manual for a 3Com phone. The bottom of this is the user guide for a 3Com phone. And so 3Com phones come with a default password. It's either 0000 or 8 zeros is the other one that it's used. So that is the default password in the system manual. Yet in the user guide it says, avoid simple passwords such as 0000. I think those two technical writers need to get together and do a little brainstorming. So by default, which this is a good thing, it doesn't have what they call detailed logging. So if you got into that, you wouldn't be able to see the actual phone numbers of people that had been called. But again, if you have access to the web interface, it's very easy to turn that on. But this was the feature that I found particularly concerning. So you can do a backup of the entire phone system, and you have the option, by default not checked, but pretty easy to check that box, please include all of the voicemail in my backup. And then you can download that, and what you get is it's just a tar file. Looks like what you see on the left, and you unpack it, and there's all these other tar files in there, and then ultimately you get to the VM directory, and it's just this alphabetical list. I assume that's based on the people's names of who has the actual phone. But Rupert loves this. All that is a WAV file. So just change the file extension to .wav. You can play that directly. Nothing else required. And then the last category is just server management. One thing that I found that was very popular was APC. They make a lot of systems to be able to monitor your server farms, and very unique server string. The whole Acme, you'll find nothing but APC. So infrastructure manager was one popular one. This was an older one because what you'll typically find is something that requires an ActiveX control to download. But once you get that, default passwords are typically used. You can actually interact with all of the hardware that is monitored by it. Another popular one was what do they call this one? NetBots. Similar thing, you can monitor all those things. Very often it has cameras that you can see into server rooms as well. Again, the same unique query string to get that stuff. So we've talked about all the different categories of, all these different buckets of things that I thought had frightening functionality if it was exposed to the web. But so what can we do about it? So one thing that I wanted to do, it was clear to me when I was doing this research that a lot of these entities that I was looking at, these weren't necessarily big enterprises. There definitely were a few of those. But a lot of these were like smaller businesses that just really didn't have the security expertise. So I wanted to create something to allow anybody without a lot of expertise to be able to quickly scan their network and be able to identify any embedded web servers that might be there. Because as mentioned, a lot of the traditional fingerprinting tools, things like Nmap, aren't necessarily designed for this. So I wanted to do something specific. I also wanted to make it purely web-based so that it was very easy to do. This, by the way, is online, available to use. Just go to brews.zscaler.com. So brews, that doesn't mean you're getting beer. I just needed a name with EWS, and I like beer. So basic request embedded web server scanner. So the goal of it was to get this simple thing that anybody could use. So it's just a PHP application, LAMP-based architecture, so MySQL, PHP. What I will do is, right now it's just online, but what I'm going to do is give out the code for the scanning component of it, because obviously to scan your LAN, you're not going to be able to do that with a web-based system. So I'll give away the scanning component that'll then talk to the back-end database, which will be out in the web, to get the signatures, and then that way you'll also be able to scan your internal network. I'll put that up shortly. If you have any feedback, please send it to me. I'd love to hear from you. So I would have liked to have done this purely with client-side scripting. Like if I could have done this with JavaScript, that would have been great. But unfortunately, because of you have same domain origin restrictions, like you can't have a web-based system and then go scan a bunch of internal machines. You can get basic things like did the URL return, but I can't grab things like server headers. So that's why I chose to do it as a PHP application. Wish list, I want to expand the signature set. And then I'd also like to work on some client-side tools like a Firefox plugin so that you didn't even need to, again, I want to make this as simple as possible so that you don't have to run a PHP server on your LAN. You could just download the browser plugin, and then that way you could interface with the server to get the signatures. So how does it work? Very simple. So the first thing, you put in your scope, and I'll show it to you in a second, what is the address range that I want to scan. It's then going to, Brews will actually run the scan of the devices, and it's retrieving all of that header fingerprinting information. Then the next step is to analyze that. So it will look at the header information it gets back, then decide on what tests are to be run to do deeper fingerprinting. So it's not relying just on the headers. It's using the headers to decide what second-level tests will then be run. Results get sent back, and then you have an optional ability to send feedback. And that's really what I want. The goal of this project is, I don't feel there's good fingerprinting information for embedded web servers. Unfortunately, a lot of these devices are sitting on LANs where we can't scan them and get it. So I want people to scan their devices, scan their LANs, and then send us information back. And I'll share this information freely. So the types of checks. So one check that it'll be doing is Regex content check. So an HP printer is a really good example of that. So based on the header, I'll know that this is likely an HP printer, but I don't know what type. Now, fortunately, there are only a handful of typical web interfaces for HP printers, scanners, and they follow a typical format, so it wasn't hard to write a few different regexes that will go through and actually return the information so that when you run the scanner, you know not just that it's an HP printer, but that it is indeed a LaserJet 2200 in that case. So content regex is one. The server response code is another, because, again, the beauty of scanning these from a fingerprinting perspective is they're pretty static. Like, people aren't putting their own web pages there. It just comes with whatever it comes with. So if I can look for the existence of a particular page, I get back a 200 that says, yeah, the page is there, then, you know, here's an example of I can tell that, yeah, indeed, this is a Ricoh copier. And Md5 checks are another approach that I used, because very often you'll have an image that's unique. Like, so that, where it says gigaset, blah, 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 WLAN, that's actually an image. So I couldn't use a regex there to screen scrape for that information, but obviously that image will be unique to any device, because, you know, if they change anything, the Md5 will change. So let me just show it to you briefly here. So because I have absolutely zero confidence in the network here, I've faked my, I sat through the femtocell talk when somebody was obviously jamming the network. So, sorry guys, I don't trust you. So basically I've just faked my machine so that it will come back looking like an HP printer. So it'll send back the right server headers. So within Bruise, I'll just scan, you know, the one machine. But obviously you can put a range in here. So that first step, it's going to retrieve the server headers. You can see it gets back the Verata M Web is the one that's unique to, reasonably unique to HP printers. But then it's going to take that, query a backend database and say, okay, I think this is an HP printer, so what additional scans should I run? In this case, it'll run the regex content checks, and then that way it's able to come back and say, yeah, you know, it's a OfficeJet server. So very simple tool. But again, I want it to be used by people that typically are not going to have the knowledge to be doing the scanning of their network, because I think those are the people that are most exposed. So another tool that I just wanted to give a shout out to, this is Andrew Horton's tool, WhatWeb. How many people have heard of WhatWeb, played with it? It's actually a really good fingerprinting tool. It's not focused on embedded web servers per se. It's focused on web applications. So rather than, like, an Nmap will tell you that this is an Apache server, WhatWeb is trying to say, oh, this is an Apache server, but it's running WordPress, you know. And it has a number of checks, about 900 plus. There is a bunch of embedded web server stuff in there. I actually talked with Andrew when I was doing this, and he was really kind and actually shared a bunch of his checks with me. And so in return, I've said, hey, whatever I collect with Bruise, I'll give back to you so that you can continue to make WhatWeb better. So another great tool. It didn't meet my needs because I wanted something that, you know, you didn't need a lot of expertise to run. And with this, you would have to have, you know, Ruby installed. And I just didn't feel that was a reasonable expectation for a typical small business. But great tool if you want to do fingerprinting to actually figure out what a server is running as opposed to just what it is. Some of the stats, so, you know, I went into this believing that most, or there, a lot of the web servers that are out there today aren't actually traditional web servers that are serving up web pages. They are embedded web servers. And so these are the stats of the million-plus servers that I looked at, and I think it proves that. Like the first two, you know, 68% of it, IIS and Apache, as you'd expect. But when you get beyond that, it is a lot of embedded web servers. Now, some of these could be a traditional web server because there's no definition that it doesn't, like, I could use some of these to run it, but a lot of these will be embedded web servers. Looking at that laid out another way, so I know what that big spike is. I know that those are the traditional web servers, but what the heck is the rest of that? Well, a lot of that is embedded web servers because there's just so much stuff plugged into the web today. These were the top 10 embedded web servers that I saw. Again, some of these, like a light HTTPD, could be used for other things, but for the most part, I found that these were in hardware devices. You'll see a mix of commercial and open source used in there. Like companies like RomPager, like Verata MWeb, those are companies that's what they do. And remember, the Verata MWeb, we saw a lot of that in the HP printers. But a lot of the vendors just go with an open source. I focused more on functionality that was exposed, but vulnerabilities are certainly a concern as well. There are a lot of vulnerabilities in these embedded web servers, and yet when's the last time you upgraded the firmware on your photocopier? Probably never. So once there's a vulnerability in a lot of these hardware devices, it's probably there for a long time. So look at three of these. Look at that Allegro ROM pager, 3 million devices that are running an outdated version with known vulnerabilities. Cross-site scripting was very prevalent. I think it is actually not an unfair statement to say that it was hard to find embedded web servers that did not have cross-site scripting. There's Xerox photocopier, here's Tektronix photocopier, and so that piece could be really valuable in a target attack. You find that web server, but it is password protected. Well, then I can do a spear phishing attack, send an email to the administrator, try to get his auth credentials that way. So cross-site scripting, very, very prevalent in these sorts of devices. So what do I think should be done about this? I really place the blame on the vendors. Like, number one, I think sometimes this functionality really serves no useful purpose. It doesn't need to be there. But, there is definitely many situations where it does serve a very, very useful purpose. But there is no way that this stuff should be turned on by default and not be password protected. I would argue that the hardware industry is at least a decade behind the software industry in terms of security. This is the kind of stuff that we saw on the software side, the operating system side, more than a decade ago. Like, it really is low-hanging fruit. Software industry was forced to climb the learning curve because they got called out. Hasn't really happened on the hardware side, and I hope that will change. As I said at the beginning, these devices should come with functionality disabled until an administrator password has been set. There should never be a situation where there's no password, and the whole idea of a static password is completely useless as well. Another thing is, it was very common that sometimes you had no way to upgrade firmware anyway, but when it was, typically the burden was on you. It was a pull system. You have to be looking for the patch. We definitely need to move to a system that's more common in, like if you have Apple TV, the new updates get pushed to you. You don't have to do anything. We need a similar system here, especially because a lot of these are in the small businesses that just aren't doing this. From an enterprise perspective, you need to treat embedded web servers just like any other web server in your organization. That photocopier should not get plugged into the wall until it's hardened, it's password protected. When you're doing your quarterly, whatever it is, scans, that embedded web server should be part of it. You should be scanning it, and not just for vulnerabilities. You have to look at this in a unique way. You're looking for exposed functionality. And it should also be part of your patch management process. So just to show you how outdated some of this stuff is, so this is Allegro ROM pager is one of those commercial versions that are very, very common. You see it. If you go to their website, they say they're in like 75 million devices. You see the Shodan results down the side. Now, version 6.1 is fairly new. I don't know what the latest is. Version 2 is very old. And yet, look at how many of devices we were able to identify. You look at version 2, 1997. Yet, nearly 4,000 devices still running that. 3.0 was 1999. Even 4.6, I guess, is not that new, April 2007. So these devices, they're still in use. They're running really outdated firmware that is likely chock full of vulnerabilities beyond the functionality issues as well. So with that, I thank you for your time. Does anyone have any questions that I can answer right now, and beyond that, I'll stay here for a little while afterwards if you want to chat as well. I see one back there. Maybe if you could shout it out, and I don't know if there's a microphone, I'll repeat it. Tell you what, honestly, I can't hear. Why don't you just come up? Thanks for your time, everyone. I really appreciate it.